Hello students. So today we are going to start with our standard 6th subject science lesson number 11, that is work and energy. So students, we already know that we have finished with this lesson, but in this particular session we are going to revise with all the doubts and clarities of this particular lesson. So beginning, as we know, work. So students, what work is? Basically, when an object is displaced by applying a force on it, then work is said to be done. There are many definitions or many other explanation to it. If you do, more work is done for the same displacement. When more force is applied to do the work, if the same force is applied for more displacement, more work is also done by the force. Now, have you seen a pulley? So when you tie a load on one of its end and you hold the pulley to the next, what will happen? When the applied force is the same, more work is done when there is greater displacement. In other words, or in simpler words, I can say, for measuring the work, both the force and the displacement is considered. Understood, students? If you want to know that how much work a particular person has done or how much work needs to be done, you have to see both the displacement, that is the movement, and the force, the energy which is applied to do that particular work. Understood? Now, the relationship between work and energy. So, the boy in this picture has applied a force to the toy car. We can see, correct? Work has been done because the force applied to the car has caused displacement. As I told you, force and displacement both are used. So, in other words, transformation of the boy's energy into work has taken place through the applied force. Now, when you run around with your friends, can your friends run as many rounds as you? No. Correct? Your friends will complete either more or less rounds than the number of rounds you complete. Correct? Some friend must be completing 10 rounds, some friends only 1 round, and some friends even only 5 to 6 rounds. Correct? Some will get tired on completing 2 rounds. Correct? While others will get tired on completing 3 to 4 rounds. That is to say, each one's capacity to complete round is not the same. So you can complete only as much rounds as you have the capacity for. The capacity to do the work is called energy. Moving to our next topic, that is forms of energy. So the very first form of energy is mechanical energy. But students, in mechanical energy, there are again more two types, that is potential energy and kinetic energy. So what is potential energy? Basically, in the picture, which is an example, we see that when the rubber of a catapult or a arrow is bow and arrow is stretched and released, it comes back to the original state and the arrow flies off. Correct? Similarly, when the spring of a toy is wound and then released, the toy starts playing. When water is stored at a height, in each of these actions displacements takes place, which means that work is done. From where is this energy obtained to do this work? This energy is obtained from a specific state or position, which is called as potential energy. Next is kinetic energy. Now we give energy to the marble or a striker and set them in motion. The energy obtained from the motion is called as kinetic energy. Next form of energy is heat energy. Okay, so from its name, heat itself, we can understand that it is related to sun. So students, the earth receives heat in proper quantities from the sun. That is how an atmospheric temperature favorable to the living world is maintained. Heat is a form of energy. Sunlight contains heat energy. Heat is produced by burning of fuel. Heat energy is used in kitchen all the time. Heat is also measured in the unit called calorie. Moving to next is light energy, students. So again, here you might have seen that we have learnt that plants make their own food with the help of sunlight. It means that light energy is transformed into the energy of food into plants and animals, and these plants and animals use this food for doing their work. It means that light is a form of energy. Understood? Basically, before starting, from the name itself, sound energy, we understand that it consists of sound. So students, you might have seen that the glass panes of windows crack due to a loud noise. Correct? If you produce a very loud noise or a very screaming noise, then the glass cracks. Okay? Similarly, sound is also used to control the movements of some toy cars. You have heard the vibrations when you're playing a remote controlled car, correct? This is because the sound helps to control the movements of those cars. This means that some work is done by sound. It tells us that sound is also a form of energy. Now, moving to our next topic, that is chemical energy, the another form of energy. Now, students, from the word itself, chemical, we understand that it is chemicalized form of energy. How? When wood burns, we get heat and light, correct? During winters, we specially do bonfires. What is bonfire? We are basically burning the woods and we are taking heat and light from it. Sometimes we also hear a crackling sound as well as, correct? When the woods are burning, you hear that crackling sounds, some sparks are coming out, correct? What makes this happen? The energy stored in wood is emitted in various forms through chemical action. Also, students, it is due to chemical action in the lead acid battery that electrically energy is produced. Basically, from these batteries there are chemical reactions which are being done, through which we get energy from this. Basically, the energy obtained through chemical action is called chemical energy. Now, moving to our next topic, that is transformation of energy. So students, now you have always observed that the working of various appliances such as fan, lamp, mixer, TV, refrigerator, everything are used on electricity. Electricity is also a kind of energy. Now, how does this happen? Transformation of energy takes place when work is done. Now, let us consider one chain of transformation of energy. For example, in the course of water cycle, what happens that water evaporates due to the heat of the sun. This we have learnt in standard 5th, correct? This water vapor forms cloud that gives rain. Now, rainwater flows into river and is stored in reservoirs or dams. These are at a height and therefore their water has potential energy in it, which is transformed into kinetic energy as the water falls downwards. When the water falls on the blades of a turbine, it is called as a wheel, okay? It is kind of a wheel. Its kinetic energy is transferred to the turbine. Now, this turbine or a wheel which is rotating produces electrical energy. This electricity gets transformed into various other forms of energy. Now, Now, electrical energy, students, is used in our houses for various purposes. It is transformed into light energy on lighting a bulb, into kinetic energy on starting a fan, into sound energy while playing a musical system, and into heat energy in an oven. Now, thus we see that we are indirectly utilizing nothing but solar energy in all the transformations of energy. In other words, the sun is the most important sources of all the energies. Now, students, energy resources. The resources used for getting energy can be classified into two types. Now, what are these two types? They are conventional energy resources, that is, non renewable energy resources, and non conventional energy resources, which are renewable energy resources. Now, the energy resources which man has been using for centuries are called conventional energy resources. Conventional energy resources include coal, fossil fuels such as petrol, diesel, natural gas. We cannot reconsider or we cannot remake these resources. Wood also cannot be remade easily. Okay, students? Same. Second one is non-conventional energy resource, which is called as renewable energy resource. These resources have not been used traditionally. They are inexhaustible and continuous and can be used in various forms again and again. Now, due to the increasing population and increasing usage of energy resources, there is a danger that the limited resources or limited reserves of coal, petrol, diesel, crude oil, and natural gas will get exhausted, that is, will get finished. Now, therefore, it will be better to use alternative and supplementary resources instead of the conventional ones. Understood, my dear children? Now, this non-conventional energy resource, or you can say renewable energy resources, also have many different kinds or many different forms. This we will learn further. So, moving to the first one, we have solar energy. Now, students, what is solar energy? Solar is basically related to sun. So, now this energy which is obtained from sun is continuous and enormous. Solar energy is at the root of all energy which is available on the earth. A variety of devices which have been developed for making use of solar energy. For example, the solar cooker, solar water heater, solar dryer, solar cell, etc. are all the kinds of uh, objects which are being used with the help of solar energy. In the first three devices mentioned above, that is, heat energy is obtained from the sun to utilize to cook food, to heat water, and to dry the grains. In the solar cell, electrical energy can be obtained from solar energy. Now, solar electrical plants have the capacity to produce electricity on a large scale. A solar plant consists of many solar cells. In this picture, it is a solar plant which is having many solar cells inside it. Okay. So the next form of energy is wind energy. So students, by the name itself, we come to know that it is related by wind. Okay. So electricity is generated by means of windmills using strong winds. A windmill is also used for drawing water from a well. You can see in this image that how windmills look. We have seen even in villages, you might have seen in your village that at the borders of your village there are plenty of windmills. Why? Because these windmills help to produce or regenerate electricity, and the whole particular town or whole particular village gets electricity through these windmills. So windmills are the basic, or you can say the part of wind energy. So students, next form of energy is tidal energy. So tidal here means tides, tides which we see in sea or rivers. This is tidal energy. Basically, a wall is constructed at a narrow region of a creek. You know what is a creek? A small part of river, or a small uh, string which is coming of water, that is creek. So a wall is constructed over there due to waves generated by high and low tides. The turbine, or I have already explained that turbine means it's a wheel. The turbine of the generator fitted in the wall starts rotating and electricity is generated through it. You can see such turbines in the picture on your screen. Now next is hydroelectric or hydropower. Here from the word hydro, it means water. Hydro means water, and electric is basically, you know what is electricity. So students, the water which is stored in a dam at a height is brought down through a tunnel, and the turbines of the generator are rotated. Now, the place where electricity is generated in this way is called a hydroelectric or tidal power plant. You can see in the picture how the dams are there and how the water is flowing through it into a great speed, and it is coming down towards turbines. Now these turbines rotate and they form electricity. The very well known power plant of hydropower plant in Maharashtra is the Koina project. There are also other small hydroelectric plants located at other dam sites also. The next is energy obtained from oceanic waves. Now this is also kind of tidal energy, but this is produced through waves, not tides. Waves are much larger, students. So while sea waves move forward in a certain direction, the water moves up and down regularly at a position. This too can be used to generate electricity. You can see in the picture on your screen that how the waves look. It is much greater than the tides. Okay students? Now moving to our last form of energy, that is atomic energy. So students, atoms, so basically from the atoms or by creating it in laboratories, this energy can be used. For example, the serious crisis of electricity shortage can be eased by generating electricity by means of atomic energy. Now how this atomic energy works, I'll show you. The heat liberated during the fission of atoms of heavy elements such as uranium, thorium is used to generate electricity. Understood? You can see in the on your screen in the picture that these are the atomic energy power plants. Now here you can see the smoke is coming out. How? By doing changes in the atoms of uh, elements like uranium, thorium. Okay, now students, we'll move to the last topic, that is energy saving and energy, green energy. So in a way, if you say that what is green energy is and how energy could be saved, I'll let you know that in a way, saving energy is as good as generating energy. Students, there are several ways of saving energy, such as putting off lamps when not needed. If you are doing some work, so if you don't need the light, you should shut it down. Same way, making maximum use of sunlight, that can also help in saving the energy. Saving energy and energy resources is very necessary. Otherwise, we will have to face a serious calamity like global warming. Now students, the energy resources which do not produce smoke and carbon gases such as carbon dioxide or carbon monoxide are called green energy resources. Greater use of such resources is the need of the hour. Okay, students? So, students, here we end with the lesson. Our 11th chapter is finished. I hope you have understood it well. We'll meet in our next class with the next lesson in our next session. Till then, thank you.